Hi students, now question number 19. What is the potential difference between the terminals of a battery if 250 joule of work is required to transfer 20 coulomb of charge from one terminal of the battery to the other? Okay, in the class we have already studied, if you take a ordinary wire of copper, how the charges are going to flow from one end of the conductor to the other end. We need a source called as battery. A source of EMF is required. So when the two ends of the conductor are connected to the two terminals of a battery, means now the charges will be forced to travel from one end of the conductor to the other end. So work has to be done. Work has to be done for the flow of charges. This work done per unit charge only must be equal to what? The potential difference across the conductor. So here what is given, you see here 250 joule of work is required. So we will list the given quantities. So the work done is equal to 250 joule, and the quantity of charge that has to travel through the conductor is Q is equal to how much? 20 coulomb. Okay. What is asked here is the potential difference. So V is asked here. So what is the potential difference across the conductor must be equal to? It is a work done per unit charge. Therefore, the formula which we are going to use is the potential difference V must be equal to work done divided by the quantity of charge. So this must be equal to what? 250 divided by, so this is in joule, and the quantity of charge is given in coulomb. So 0 0 getting cancelled, the remaining is 25 by 2. So 25 by 2 is 12.5. This is a joule per coulomb. So joule per coulomb also is having another unit that is called as what? Volt. Okay. So we will write the potential difference V is equal to 12.5 volt is the required answer. Very simple, direct numerical problem. Understand? Now question number 20. How much work is done in moving a charge of 2 coulomb across the 2 points having a potential difference of 12 volt? The same or similar problem using the same formula only, but the quantity asked here is work done. How much work has to be calculated? So in this problem, what are the given quantities? 2 coulomb. So quantity of charge is given as 2 coulomb, and the potential difference V is given. So that is equal to 12 volt. And what is the work done is asked. So same formula only, is it not? The potential difference V is equal to work done per unit charge, or work done is equal to potential difference into quantity of charge, and this is now the product of 12, okay, and 2. So simple multiplication, 12 2s are 24. So this must be equal to 24. Therefore, W is equal to 24, and the unit is joule here. So work done is 24 joule. So both the numerical problems are very direct and very simple and easy. I hope you must have understood both. Fine.